Okay, what I'm going to do is go over those homework problems. We did the first one in class. It's fairly straightforward, this first problem of relative velocity, because we are just working in one dimension. So we had our cyclist going along a straight road at 10 metres per second. He's travelling east. The car is also travelling east at 28 metres per second. The gap between them is 360 metres, and the question is asking you how long it will take for the car to catch the cyclist. So how long will it take it to bridge this 360 metre gap? Okay, the relative velocity of the car compared with the bicycle is this minus this, which is 28 minus 10, which is 18 metres per second. So the relative velocity of the car compared to the bike is 18 metres per second. And then we can put these numbers into our velocity equation, which will give us 20 seconds. So it's going to take 20 seconds for the car to bridge this 360 metre gap. Alright, on to the more challenging ones. Alright, now we're looking at doing it in 2 dimensions. So, this is our scenario. Car travelling, that's north, it's our compass. Our car travelling due south at 100 kilometres an hour. Alright, we can keep kilometres an hour here because everything's in kilometres an hour, so we don't need to change it. And the magpie flies in a westerly direction at 20 kilometres an hour. Okay, over the road. What's the velocity of the magpie relative to the driver of the car? Alright, so what we need to do is to work out the relative velocity of the magpie to the driver of the car. It's the difference between the speed of the magpie in the ground, which is 20 kilometres an hour, the difference between that and the car and the ground, which is 100 kilometres an hour. Okay, now let's not forget that these are in separate directions. This one is west, this one is south. So it's in 2 dimensions, so we can't just simply subtract one number from the other. So we're going to draw a vector diagram. And 20 kilometres an hour west minus 100 south. So we flip this to go like that. Okay, and we draw the vectors in this order. And that's where I got hung up this morning, is in order that they appear in the formula. So 20 west minus 100 south. So our resulting vector is from the base of the first to the tip of the second, and so it's the hypotenuse of this triangle like this. And now it's easy for us to work out the magnitude of this. Okay, using Pythagoras' theorem. This is 20, this is 100. Punch those numbers in and we get, what do we get? C equals 102 kilometres an hour. Alright, now we need to know what angle the magpie is going to appear to be coming from relative to the driver of the car. So it's this angle in here. So we've got our opposite, we've got our adjacent, so we're going to want to use tan. Alright, opposite over adjacent. Opposite is 20, adjacent's 100, tan, theta. So theta is going to be equal to the inverse of tan. We have 100, so 20 divided by 100 equals inverse tan. Theta equals 11.3 degrees. Okay, so the angle in here is 11.3 degrees, and we need to put these coordinates back into our points of the compass. Alright, so it's 11.3 degrees in here, means it's going to be 11.3 degrees up in here. So the relative velocity is 102, and this is our north, and this angle in here, the same as this angle in here. And so that's 11.3 degrees. So its final velocity can be stated as 102 kilometres an hour. Remember, we didn't change it, we were working kilometres an hour. North, 11.3 degrees west. That's it. Alright, I'll stop this one and come back.